All right, let's dive into something that's way more than just lines on a page. We're talking about the coordinate plane. And honestly, it's the map for pretty much all of algebra. Ever really stop and think about it? You pull out your phone, open up a map, and bam, there's that little blue dot showing you exactly where you're standing. How in the world does it know? Is it some kind of tech magic? Well, not exactly. The secret is actually a pretty simple idea you're about to get really good at. It's a grid. Think of it like a universal address system for any point you can imagine. And this system is the engine behind so much of the tech we use every single day. So let's unfold this map. Okay, to really get this, let's pretend we're building a brand new city from the ground up, right? Any good city needs a super clear way to find any address. And that all starts with two main roads. So our first main road is the x-axis. This is our big horizontal street running east to west. Think of it this way. If you move to the right, you're heading into positive territory. If you move left, you're going negative. That's it. Now, you can't have a city with just one road, right? You need a crossroads. So our second main street is the x-axis. This one runs vertically, think north and south. Traveling up, that's positive. Heading down, that's negative. And that spot where these two huge streets intersect, well, that's the heart of our city, the dead center of everything. We call it the origin. Its official address is 0, 0, and it's where we start every single time we need to find a new location. So just lock this in. Every address, or what we call a coordinate, always gives you two pieces of information. The first number, the x, tells you how far to go left or right. The second number, y, tells you how far to go up or down. All right, our city map is all laid out. Now let's actually put it to work. Let's try to find a specific address. Okay, let's find the point 3, -4. Step 1, you always start at the origin, right there at 0, 0. Step 2, our x value is a +3, so we move 3 spots to the right. And then step 3, our y value is a -4, so from that new spot, we move down 4 units. And there it is, we've plotted our point. Now, if you look closely, you'll see our two main axes actually chop our city up into 4 different neighborhoods. In math, we call these quadrants, and each one has its own vibe, its own unique personality, all based on the signs of the addresses inside it. And each of these neighborhoods has its own rules. Over in quadrant I, everything's positive, both x and y. But hop over to quadrant 2, well, we had to go left, so x is negative, but we're still up high, so y is positive. You see the pattern here? It's a totally logical system for the whole grid. So this is where it gets cool. If I ask you to find the point -2, 5, you don't even have to draw it to know where it is. Just think. The x is negative, so that's a left turn. The y is positive, so that's up. Left and up, well, that can only land you in one place, quadrant 2. Easy. Now, just like exploring any new city, it's pretty easy to make a wrong turn at first. So let's talk about the 2 most common mix-ups so you can navigate this thing like a pro from the get-go. The number 1 mistake, hands down, is mixing up x and y. Just remember the alphabet. X comes before y. So you always deal with your horizontal move first. I like to think of it like this. You have to walk to the elevator before you can go up or down in it. Walk, then ride. X, then y. So what happens when a 0 shows up in the address? Let's say you have a point like 0, 3. That 0 for x means you don't move left or right at all. You stay put and just go straight up 3. Your point ends up right on the y-axis. It's not in a quadrant, it's on a border street. So why do we just spend all this time building a pretend city? Well, let's circle all the way back to that question I asked at the very beginning about your phone. How does this simple grid relate to a global positioning system? This pretty much says it all, doesn't it? That incredibly complex piece of technology in your pocket? At its core, it's running on the exact same simple principles we just covered. It's just doing it on a much, much bigger grid. Think about it. On a world map, what we call longitude is just the x-axis. It tells you how far east or west you are. And latitude? That's just the y-axis, telling you your position north or south. Every single spot on this planet has a unique x, y coordinate, and your phone is an absolute genius at finding it. Okay, let's bring it home. What we've done here is a lot more than just learn how to put some dots on a graph. We've actually laid the foundation for pretty much everything you're going to do in algebra, and honestly, a lot of math after that. You now have the key. You can take any pair of coordinates and find its exact location. You can look at any point and know its neighborhood, its quadrant, instantly. You've learned the fundamental language of the map of algebra. But here's the thing. This is really just the beginning. One point is just a single address. What happens when you start plotting a whole bunch of points that all follow a certain rule? Well, they form lines, they form beautiful curves, they form parabolas. Every single one of them tells a story. So the real question is, what story are you going to tell next?